Hi, Marina.
Hi.
How are you doing today?
Good, and you?
Good. You must be getting ready to finish up next week. When is your final?
We already had it. Tuesday's our last day of school.
Okay.
This is Rostina. Hi, Dave. How are you doing?
Hi. Good, Rosina. How are you? I'm fine. How are you doing?
Good. She just has these assignments that she needs to complete, I guess.
Uh-huh.
Hopefully we'll bring her grade up a little bit.
Okay. Well,
I wanted to ask you, because she's right on the borderline grade-wise, from a D to a C. Do you think she should have her as Algebra 1 honors, but we can decide either put her in geometry or Algebra 1 honors, so she would get bored again with Algebra 1? Do you think she should continue, or I was just curious about your thoughts? Either do Geometry 1 or retake Algebra 1 in honors.
Yeah, that's a tough question. Let me think about it a little bit before I give you an opinion. I'm not really sure what would be best for Marina at this point.
Because I'm strong in some parts.
Yeah. What grade is she in this year?
8th grade.
So she'll be in ninth grade next year.
Yeah, so she's really a year ahead in math.
Yeah.
But algebra, since last year, she took pre-algebra, and she didn't really have such a strong teacher, kind of, I guess. And this year, it's a much better teacher. She's figuring things out. But, I mean, as you know, we had to ask her to help.
If she takes geometry next year, she would take Algebra 2 in 10th grade.
Right.
And probably pre-calculus in 11th grade.
Right.
And either calculus or probability and statistics or college algebra as a senior. So certainly if she took geometry next year, she would have no limits as to how far she could go. If she takes algebra again next year, I don't know. Let me think about that a little bit more. Yeah.
I mean, we can really do whatever we want in reality, because she's not flunking.
Right. Right.
So it's really, and the counselor said that whatever we decide, whatever she wants, we'll do. And the high school knows this, and we're kind of pending on which direction to go. So
okay. Let me think about it a little bit and see if I can come up. If it was my son, I'm not quite honest what I would do. So let me think about it a little bit before I give you. I
appreciate that. Thank you so much.
All right, Rosina.
And I know you have Joel today, right, at 7 p.m., is that correct?
Yes. Yes, I do.
Okay. Okay, because he signed up for yesterday at 8, but he forgot to do the last movement, and so he resigned.
Oh, okay. Yeah, I wondered what had happened because he had indicated he wanted a session yesterday evening.
And he forgot to sign in all the way. You know, I have to press twice, okay, to confirm. And
yeah. Okay.
So no worries. I just want to make sure he did it right this time.
Yes, I do have him.
Okay, thank you.
All right.
Here's Marina.
Okay. So what are you inclined to want to do, Marina? Are you inclined to want to take algebra again or geometry?
Well, if I took it again, it'd be, I'd have 3 years of algebra. And, and like, I have strong parts in algebra, so I think it'd be good enough to go up.
I kind of think you would be too. Geometry is about half algebra and half geometry. Don't think that just because it's geometry you don't do any more algebra. You do.
Yeah, you use algebra and everything.
Yes, for sure. And in fact, it might be more algebra than geometry. But I'm inclined to think that you'd be okay in geometry. That'd be my initial reaction. All right, let's take this first one. Y equals 3x squared minus 6x. In order to graph that, what do we need?
To find the vertex.
Okay, let's find the vertex x-coordinate. What is that? General formula?
Is negative b over 2a.
And I think it would help you if you start out every problem like this, where you write it out and write the general formula always. Okay? So what is minus b here?
It'd be 6 over 6.
So that's the x-coordinate of the vertex. What's the y-coordinate of the vertex?
Don't you plug in 1 for x?
Uh-huh.
Okay. And so it'd be y equals 3 times 1 squared minus 6 times 1.
Uh-huh.
So it'd be 3 minus 6, so it'd equal negative 3.
Okay. So now we can graph it. So we go to the point 1, negative 3. And that's our vertex. Does this go up or down?
Up.
Okay. And what's the easiest thing to get us? In other words, I know it's going to be an upward parabola, but I don't yet know where it crosses the y-axis, and I don't know where it crosses the x-axis. So in order to graph it accurately, we need one of those points. What's the
Can you
easiest?
find the x-intercept?
Well, that's one way to go. There's actually an easier way to go, in my opinion, and that's to find the y-intercept. What's the y-intercept here?
Do you replace y for 0?
No.
Or I mean,
X for 0. In other words, whenever we cross the y-axis, that's where x is going to be 0. So what's...
0?
Yes. So we know it goes through that point right there. We know its vertex is right there. Do I know another point just from that information? Remember that parabolas are symmetrical about the line of symmetry.
So then it would be 2.
2 what? 2 comma 0. And there's your 3 points to plot this parabola. Notice how much easier it was to find the y-intercept than it is to find the x-intercepts. However, just for practice, let's find the x-intercepts. How do we do that? I mean, we already found them, but let's verify that we have the right ones. What is 0 when we have x-intercepts?
Y.
Okay, so I'm going to substitute 0 for y, and I'm going to solve this equation. What's the next step?
Divide everything by 3x.
Factor out a 3x, because this is now a factoring problem. Since I've got 0 on one side, I want two things multiplied together on the other. So after I factor out a 3x, what do I have left here?
X minus 3.
What is 6x divided by 3x?
2.
2. Okay. And that gives me my x-intercepts. What are they? Set this one equal to 0 and set this one equal to 0. What are my x-intercepts?
X equals 0 and x equals positive 2.
Notice that's exactly where we cross the x-axis, even though we did it a different way by finding the y-intercept. But notice how much easier it was to find the y-intercept. Because all we had to do was plug in 0 for x, and we had the y-intercept. So it's always going to be easier to find the y-intercept. Finding the x-intercepts requires you to factor. Okay? All right, let's replace that with another one. I think it's good on these if you understand a couple of ways to do it. Helps your understanding of it, I think. First step.
Negative b over 2a.
Equals what?
Equals 24 over negative 12.
Equals
8 over
what's 24 divided by negative 12? What's 24 divided by 12?
2
So what's this?
over 1.
So that's negative 2. Next step.
Plugging in negative 2 for x.
Finding the y-coordinate of the vertex, which we do by doing this. When you say plug in negative 2, it's the same as that. It means y of negative 2, meaning minus 6 times negative 2 squared minus 24 times negative 2 plus 17. Okay? What's this term?
Negative 4 times negative 6.
Okay, when you square negative 2, what do you get?
Oh, a positive.
Okay, so it's positive 4 times a negative 6.
Oh, 24.
It's negative 24. This negative 6 does not get squared. Only the negative 2 gets squared. And when you square negative 2, it's equal to 4. And then when you multiply 4 times negative 6, you get negative 24. What's this term over here? You hear me, Marina?
Yeah.
Okay. What's this term here?
It's positive 48.
Plus 17. Negative 24 and positive 48 is positive 24. And then 24 and 17 is 41. So there's our vertex, minus 2, comma 41. Okay, let's plot that. Minus 2, comma 41. Oh, we forgot to do one other thing on the first one. A couple of other things. Negative 2, positive 41, right? Well, we're going to call that right there. -2, +41. Is it up or down?
Down.
Okay, so we know something looks like that. What's the next best point to try to find? How about the y-intercept? Where is that?
Uh, 17.
Right. Now, isn't that easier to figure out than anything else?
Yeah.
Okay, so that is 0, 17. What's another point on our curve? Given that everything has to be symmetrical about the line of symmetry. If 0, 17 is on this curve, then this point right here is also on that curve. What are the dimensions, or what are the coordinates of that point right there?
Oh, -3.
-4.
-4. 17.
Right. So now I have 3 points. And that's usually considered enough to plot a parabola, but your teacher may want you to put the x-intercepts on there also. Well, to get the x-intercepts, we have to factor this thing. Always. Set it equal to 0, because you get x-intercepts when y is equal to 0. What's the next step here? What don't we like about this that's going to make it difficult to factor?
The 17, so you subtract
Not the 17, no. Whenever we have a quadratic that has a number in it, and this is exactly that, notice the first one was a quadratic that didn't have a number in it. That was quite easy to factor. This is a quadratic that has a number in it. This means we're going to have to factor it into 2 parentheses. But before we do that, let's get rid of this minus sign. How do I get rid of the minus sign? What can I divide both sides of the equation by to get rid of the minus signs? The only one I care about is the one in front of the x squared term. I don't really care about this minus 24 here. I don't know how to factor if I have a minus sign in front of the x squared term.
divide everything by -1.
Good. That makes it plus 6x squared plus 24x minus 17. When I divide 0 by -1, I still get 0. So now we have something that's much easier to factor. So let's factor. Now, there's a little bit of art to factoring when you have a coefficient in front of your x squared term. Normally, I suggest people start with factors of 6 that are closest together, which would be 3 and 2.
Yeah,
So
I guess.
let's try that. 3x times 2x. Now what?
that, or numbers that add to 24, but
Well, no, not really. In other words, the moment you have different coefficients in front of your x terms, you can no longer say things like factors of 17 that subtract to 24 or factors of 17 that add to 24. That's no longer the case. Now we just have to, we know that the negative sign means that one of these has to be plus and one of them has to be minus. That's all we know. Well, there's not very many factors of 17. That's 17 and 1. So I'm just going to experiment with a couple here. Does that work? Well, 17 times 2x is 34x, minus 3x would be 31x. That's not our middle term. So clearly that doesn't work. How about minus 17 and plus 1? Notice that this is a different solution. Well, this is minus 34x plus 3x. That doesn't work either. Well, there's one last thing we can try, and that's plus 1 minus 17. That just makes the problem worse. That doesn't help. So 17 and 1, no combination of 17 and 1 gives us 24 in the middle. So let's go back and try different factors of 6. We've got 6 and 1. Okay, now we still only have 2 factors of 17. Well, the thing that looks like it would be most likely to work would be that. But that gives me minus 17x plus 6x. That's minus 11x. That doesn't work. And certainly the other way doesn't work. So I have found a problem that I cannot factor. If I cannot factor it, what am I left with as my only alternative for solving for x? What is x equal to if I can't factor?
0.
Minus b plus or minus the square root of b squared minus 4ac over 2a. In other words, I use the quadratic formula whenever I come across a quadratic that I can't factor. And this will give me the x-intercepts. They will undoubtedly not be whole numbers. If they were whole numbers, I would have found it by factoring. But they're probably decimal numbers or irrational numbers. They're not necessarily imaginary, but they're not whole numbers. So I'm suspecting... Have you had the quadratic formula?
Yeah, we have.
Okay, well, let's figure it out. Let's just go through this. What's minus b?
It would be negative 24 plus or minus 24 squared minus 4 times 6 times negative 17.
Is that a positive or a negative number inside the radical?
Where?
Is this part of it, which is called the discriminant, is that positive or negative?
Negative.
Actually, we're going to be subtracting a negative number. So this part of it is going to be positive. And since this is positive and we're adding to it positive, it's going to be positive. That's a good thing. We need the discriminant to be positive. If the discriminant is negative, we don't have any solutions to this thing. So the fact that it's positive is a very good sign. And we can certainly go through the arithmetic here and use a calculator to figure out what these two values are. but those values are going to come approximately there and there. So if I extend my parabola down, it's going to go through whatever those two values of x are. I don't think it's worth us taking the time to figure them out. Let's talk about something else. Describe the domain and range of this. It's the domain.
Oh, did we describe the domain and range on the last one?
No, we didn't, and we'll go back and do that.
Okay.
What's the domain?
The domain is less than 41. X is less than 41.
Remember, domain is what the x values do.
Oh, it's all real numbers.
And what's the range? That's what the y values do.
Range is y is less than or equal to 41.
Not 41. What is this value right here? Ah, that is 41. Excuse me. I was reading the wrong point from my graph. I was reading this point here. Okay, yes, you're absolutely correct. So let's redraw real quickly the other one. Before we do anything, let's finish this one. Let's compare the graph of this to y equals x squared. Y equals x squared looks like this. So what does this do relative to that? What's the first thing it does?
It reflects
Across
the x-axis.
What's the next thing it does? We got a left right and an up down.
It translates up 41.
And
Translates left 2.
okay. Now, it's possible that there is some squeezing or fattening going on here. We can't really tell from the way we drew it. But in all honesty, I don't think she wants you to consider that as to whether there is vertical stretching or shrinking going on. I could be wrong, but I'm going to go off of that assumption. Let's look at the other one. The other one was an upward parabola whose vertex was at 1 comma minus 3. 1 comma minus 3. It went through that point and that point, so it looked like this. Domain and range. Domain,
All real numbers.
range,
Y is greater than or equal to negative 3.
translation.
Down down 3 and right 1.
Very good. You're getting it with as fast as you answered there. All right. Now, this is a little different. This leads me to believe that tell me what the standard form, tell me what the vertex form of a quadratic is.
For vertex, I've only learned negative b over 2a.
Okay. This is the vertex form of a quadratic. Notice that this equation is in the vertex form exactly. What is A?
1.
What is H?
6.
What is K?
Negative 2.
H and K are our vertex. So notice the advantages of having it in vertex form. We don't have to go through and do a minus b over 2a and then figure out what the y coordinate is going to be. We have it staring at us in the face. It's 6 comma negative 2. Right there, there's the vertex. 6 comma negative 2 based on H and K. Does this open up or down?
Up.
Okay. Let's find out the x-intercepts. The only reason I'm saying the x-intercepts is because we could find out the y-intercepts, but we're so far away from the y-axis that it's liable not to cross the y-axis until it's off of my page. So let's figure out the x-intercepts instead, even though it's a little bit harder. What do we do to figure out the x-intercepts?
Replace y with a 0.
Now solve this equation, and this is something you can actually do without factoring.
Add 2.
Okay? Now what? Here's the difference
Find the square root.
of both sides. What's the square root of the right side?
It would be x minus 6.
What's the square root of the left side? And don't disappoint me. It's the thing you always forget to put on there.
1? Or is it plus or minus 1?
Plus or minus, but it's not 1. We have to take the square root of the left side. Square root of 2. But that plus or minus is extremely important. Why? Because it gives us the ability to find both x-intercepts. So what is one x-intercept?
Would be x equals plus or minus the square root of 2 plus 6.
Okay. That's two solutions made in one right there. What are they? What's my one solution? X equals what? Take the
positive square root of 2 plus 6.
and what's the other solution?
Negative square root of 2 plus 6.
Beautiful. Okay. Square root of 2 is about 1.4. So the first solution is at about 7.1. So this is 7.1 comma 0, goes through the x-axis. The second solution is minus 1.4 plus 6. So this is 4.6, about right there. So this is 4.6 comma 0. Excuse me, 4.6. And now I can draw my graph. And typically, if you have the x-intercepts, you don't need to find the y-intercepts. In other words, 3 points are normally enough to plot a parabola. What is the domain of this?
All real numbers.
And what is the range?
Y is greater than or equal to -2.
Good. And how does this graph compare with y equals x squared?
It's skinnier.
Hold on, let's just do an up and down or a right or left first of all.
It translates down to.
Okay.
And it translates to the right 6.
Okay. Now, in this particular case, we actually have enough information that we can tell whether it's skinnier or fatter. In the others, we didn't. But in this one, we do. And don't base it on how I drew it. I didn't draw it very accurately. Let's go back and look at it in this format, or the original equation. Notice that we can get the translation from the equation. We don't have to get it from the graph. I'm betting you got it by looking at the graph. But notice if we look at the equation, it's all set up for a shift right of 6 units and a shift down of 2 units. This is the vertical shift. This is the horizontal shift. And the coefficient in front is the vertical stretch or shrink. So what is it? What's the coefficient in front of the x minus 6 squared?
1.
So what kind of vertical stretch? Is it fatter or skinnier or the same?
Skinnier.
No, it's the same. If that vertical coefficient is 1, then it's exactly the same. In other words, the only thing we have going on here is down 2 and right 6. Other than that, the parabola we draw is going to have exactly the same shape as y equal x squared. Now, if I were to make this a 2, now it's skinnier by a factor of 2. But as long as that A is the vertical stretch factor, and in our case that A was 1. This is a very important formula right here. This is the vertex format. As you can see, that's a much superior format when we're having to graph, because it allows us to plot our vertex instantly and not have to go through any math at all to plot the vertex. All right, let's go to the next one. Again, we have vertex format. How nice. Only this time, it's plus 1, it's minus 2, and there's a negative sign in front. So what's the vertex? What is the x-coordinate of the vertex, and what's the y-coordinate of the vertex?
-2, 1.
Now look at this format again. H is the x-coordinate of the vertex. What is H?
Oh, 2, 1.
Okay, so it's 2, 1. So this thing plots right about there. There's 2, 1. Does this thing go up or down?
Down.
Okay. And since it goes down, we know that there's going to be some x-intercepts. Let's figure out what they are. Let's solve this equation. First step.
Subtract 1.
What's the next step? What's the next step?
Can you hear me?
Yeah. What's the next step, Marina?
Find the square root of both sides.
Not yet.
Or divide each side by -1.
There you go. Now take the square root of both sides.
Sorry, that was my mom.
What's the square root of the left?
1.
No.
Plus or minus 1.
Okay. It's the square root of the right. You see how important that plus or minus 1 is? Why it's so important to put the plus or minus?
Yeah, because then without it you can't find both your solutions.
Exactly. So what are my solutions? Marina? Oh, excuse me.
X equals plus or minus 1 plus 2.
Okay, plus or minus 1 plus 2, which gives me two different answers, or two different solutions.
X equals 3 and x equals 1.
Very good. That's our x-intercepts, 1 and 3, right there. Now we know what this parabola does. What's the domain? Domain.
Oh, all real numbers.
What's the range?
Y is great or less than and equal to 1.
Very good. How does this compare to y equals x squared?
It reflects.
First thing is it reflects across the x-axis. You can't just say reflects because you're going to get to a point where sometimes they reflect about the y-axis. So you have to say reflects across x. What else do we do?
Translates up 1.
And
And translates right 1.
1? How far is that dotted line from the y-axis?
Oh, 2.
Okay. Now, is there a vertical stretch factor? Or, in other words, is there a skinning or fattening of this parabola?
No.
There isn't, because the coefficient is actually -1. The minus part is what causes the reflection, but the 1 part means it's exactly the same as y = x squared. There's no vertical stretch taking place. There's no vertical shrink taking place. Okay? Again, if that was -2, it would be skinny. It would be like this. In other words, it would still reflect, but now you would have a vertical stretch factor, which would make it twice as skinny. But so far they haven't given us any of those. So I'm not sure if you'll be tested on those vertical stretch factors or not. Okay. Now, the rest of these problems look hard because they're word problems, but they're not at all hard. Notice that word problems always turn into quadratics. At least these are going to. All right, if you have 200 meters of fence to enclose a rectangular pet kennel. There's the rectangular pet kennel. And what do we know? The perimeter is equal to 200 meters. Because if you only have 200 meters of fence, then you can't make the perimeter any greater than 200. You won't be able to fence it in. Write an expression for the length of the pet kennel in terms of x. Where x, hello?
What?
Yeah.
Froze. I didn't hear what you said.
Well, I'm looking at this problem and they've left out some key information. You can't really solve it the way they've expressed it. Because they haven't told us anything about the relationship between the width and the length. In other words, if I make this dimension y, then I can say that 2x plus 2y equals 200, the perimeter, but that's all I can say. They haven't said anything about how the width compares to the length. So I'm not sure what they expect us to do here. I think she's made a typo, to be honest with you. Write a function a expressing the area of the kennel in terms of x. Again, we don't know what the width is. If she'd have said a square pet kennel, we'd have been fine. But she didn't. She said rectangular and she didn't specify area. She says for part B, write a function a expressing the area of the pet kennel. Well, that's pretty easy. Area is equal to x times y, but that doesn't help me a lot. Yes, it does. Okay, I can determine y. Let me solve this equation for y. So I got 2y equals 200 minus 2x, or y equals 100 minus x. So now I can go into area and say x times y, well, y is 100 minus x. So now area is 100x minus x squared. So there is B. Okay, I get it now. I get it. I understand what they're asking for here. If,
Wait, so do you just do A or?
well, let's go back and do A. I get what they mean now. If x is the width of this rectangle, the long dimension, and y is this dimension, well, I can solve for y in terms of x, write an expression for the length of the pet kennel in terms of x, where x is the width. So if I want, this is true, 2 times the width plus 2 times the length equals 200. Therefore, y equals 100 minus x. So now if I want an expression for the length, that's it. The length of the kennel is 100 minus x if the width is x. So that's what they were looking for in A, was this is the answer. Can you hear me?
I didn't hear anything you just said.
Can you hear me now?
Yeah, now I can hear you.
You can hear me now?
Sorry,
Okay.
can you repeat that?
Yeah. Okay, so first of all, let's go back here. I probably confused you a little bit. They said x is the width of the kennel. Let's make that x, which makes y the length. Okay, let's start there. We know that the perimeter is 2x plus 2y equals 200. That's this equation right there. So, and y is length, x is width. If I want the length as a function of x in terms of x, then I want to solve this equation for length. And when I do, I get y equals 100 minus x. So this is the answer to 5A. That is the length of the kennel in terms of x. Whatever x is, the length is 100 minus x.
Wait, so it's... Oh. Okay, I get it.
All I've done is set up an equation for 2 times the width plus 2 times the length equals 200.
But then what does x equal?
Well, we don't know. We don't care. What they want to know is what does the length equal in terms of x. So all I have to do is solve for y. Y is L. I could call this W and L if you prefer. Let's do that. I'll make it a little bit simpler. There's W, there's L. And now L, the length of the kennel, is 100 minus W, or x. Since they ask for it in terms of x, there's your answer for length. Now, what is the area of the kennel? 5B. Area is what? What's the formula for area of a rectangle?
Length times width.
So that's x times y, and y is L, so it's really x times 100 minus x. Which is 100x minus x squared. That's the area. Notice that that's a quadratic. Find the maximum area of the pet kennel and the dimensions of the pet kennel. Well, the maximum area is going to occur at the vertex. Where does the vertex of this thing happen? Of this function? We'll just write it like a quadratic. That's the area. And the maximum area, this area function is going to look like that. And the maximum area is going to occur right there. So what's minus b over 2a?
Negative 100 over negative 2.
Which is 50. So the x-coordinate of the vertex is 50. Find the maximum area. Well, is all this tells us is that we have a maximum when x is 50. Well, if I substitute 50 in here and solve for area, I get 2,500. Merely by plugging in 50 for x and getting the y coordinate, oh, excuse me, hold on. It's not quite right. 2,500 plus 5,000 is 2,500. No, it isn't. The y, the length has to be 50 also. Because remember, the perimeter is 200. So if x is 50, this side has to be 50. That only leaves 100 to split up in the length. So it has to be 50, 50, 50, 50, and it has to be a square. So the maximum area of this pet kennel is going to be 50 times 50. So area, which is x times y, is 50 times 50, 2,500 square feet. And you will find that whenever they give you a shape, and they say, what's the area that results, or what's the shape that results in the maximum area? It's going to be either a square, or a circle, or an equilateral triangle. It's always going to be the most efficient shape. Squares are more efficient than rectangles. Circles are more efficient than ellipses. If I gave you a certain amount of fencing material and I said design a round fence for cattle, you're going to discover that you get the most area if you design a perfectly round fence, not a fence like this. Same thing with rectangles, same thing with triangles. If I have a certain amount of fencing and you say make a triangle around that fence, you're going to find that an equilateral triangle gives you the maximum area. So that's a good thing to keep in mind at the back of your mind for problems like this. We know that the maximum, the best area to design this kennel is a square, not any other kind of rectangle. It's always going to be a square if it has to be four-sided. Okay, let's call it a session. And let's see, I see you again, not at all.
I haven't made any more sessions yet.
Okay.
I'll probably make.
Okay. Sounds good. I will
Okay,
talk
thank you.
to you next time, Marina. Bye-bye.